Unit 12, Day 5. More fun with radians. So, on your homework, you were going through and taking radian measures and converting them to degrees and vice versa. So this wheel, taking a look at it, starts us off from 0 and works our way counterclockwise through our degree and radian measurements. 30 degrees, as you'll recall, pi radians is 180 degrees, so this is pi divided by 6. 180 divided by 6. And then we work our way all the way around. So, as you look at this, there are some key numbers that you're going to want to know. So, pi over 3, 60 degrees. Pi over 4, 45 degrees. Pi over 6, 30 degrees. Pi over 2, 90 degrees. Pi, 180 degrees. 3 pi over 2, 270 degrees. And 2 pi, 360 degrees. So really, I would have swapped these. They're not in order. But these are your general measurements going across. When you have these memorized, it just makes the math go a lot quicker as you go through. Coterminal angles. In order to find a coterminal angle for any angle measured in radians, then add or subtract any multiple of 2 pi, since there are always 2 pi radians in a circle. So essentially what this means is, if you have your graph and you're told you're going to go around 4 pi, well, what is that angle measurement, coterminal angle? Well, we go around 2 pi, and then we go around 2 pi more, or we could say we're back at the very beginning, etc. So we're going to show several examples of this. So first, pi. Well, it's asking us to find one positive and one negative coterminal angle for each. So first we can add 2 pi. That gives us 3 pi. Or we can subtract 2 pi. And that gives us negative pi radians. Negative 3 pi over 2. Again, we can add 2 pi, but since it's over 2, we're going to write this as 4 pi over 2. So negative 3 pi over 2 plus 4 pi over 2, think of it as negative 3 halves plus 4 halves pi. So we just get 1/2 pi, or just pi over 2. For the negative coterminal angle, we will subtract 4 pi over 2. And therefore we get negative 7 pi over 2. 13 pi over 6. Well, already we see that we can subtract, because this is 2 and 1/6 pi. So we can subtract 2 pi from this, and we get pi over 6. That's a positive. And then for the negative, we're over 6. So we'll take this value, and we'll subtract 12 pi over 6 from it. So 1 pi over 6 minus 12 pi over 6 is negative 11 pi over 6. 5 pi over 3, we will add 2 pi, which we will write as 6 pi over 3. So that is 11 pi over 3. And we will subtract 6 pi over 3. Draw an angle with the given measure in standard position and find a positive coterminal angle with 1 revolution. So 9 pi over 4. Well, first what we know is 8/4 would be 2. 8/4 pi would be 2 pi. So really I have 2 pi plus another pi over 4. So that means we would go all the way around the circle once. I won't draw that. But then we come up to pi over 4, or 45 degrees, when we subtract 8/4 pi. Negative 17 pi over 3. Well, let's see. 17 over 3. I want to take away, well, actually I want to add 2 pi to that. So that's 6 pi over 3. That won't get me there. I'll have to add another 6 pi over 3. And really, I'm still a little short. I'll have to add another 6 pi over 3. So when I do that, I'll add 18 pi over 3, which gives me 1 pi over 3, positive. So pi over 3 is 60 degrees. Might be a little short there. Let me just fix this. Should be 2/3 of my angle here. So maybe more like this. You don't have to be perfect. Trig values. In order to find specific trig values, find the reference angle, which, as you'll recall, is the angle between the line and the x-axis, and then decide on the sign based on this. So here we've drawn out our quadrants. Quadrant 1 starts in the upper right, quadrant 2, upper left, and we go around counting counterclockwise. So in quadrant 1, all values are positive. We're not going to go into it much here. But here I've drawn out in green sine. In the purplish red, cosine. And in the purple, the tangent for our various values. The lines are our quadrants. Here is pi over 2, or 90 degrees, pi. 3 pi over 2, 270 degrees, and then 2 pi, 360 degrees. So what we see is in quadrant 1, all 3 functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Well, and, of course, cosine's inverse, 1 over cosine, is secant. So it's positive. So wherever the parent is positive, the inverse is also positive. So A, all. S, sine. T, tangent. C, cosine. An easy mnemonic for this is A, smart trig class knows which values are positive in the quadrants. In a circle, we have a point, xy. The size of the circle determined by radius r. The x, if we look at an angle, the x value is the adjacent side. The y will be the opposite side of the triangle. So as a reminder, we would number our quadrants in counterclockwise fashion from upper right at quadrant 1. So cosine, we have x over r, or adjacent over hypotenuse. So here we have positive, positive. Quadrant 2, only sine is positive. So if we had an angle here, we would have adjacent, which is negative, divided by our radius, which is a positive number. So that would be negative. And then in our third quadrant, we have x, which is negative, and our radius, which is positive. So it's negative here. And in our fourth quadrant, our adjacent, our x value is positive, and our radius is positive. So it gives us cosine positive. And similarly, the inverses, 1 over a positive number is positive, 1 over a negative number is negative. For sine, we have opposite over hypotenuse. So in quadrant 1, sine is positive because the opposite side, y, is positive. In quadrant 2, y, again, is positive. In quadrant 3, y is negative. And in quadrant 4, y is negative. Our tangent, which is going to be our y value over our x value, because tangent, TOA, equals opposite over adjacent. So in quadrant 1, I have a positive y over a positive x. That gives me a positive tangent. Quadrant 2, I have a positive y over a negative x. That gives me negative for tangent. Quadrant 3, I have a negative x over a negative y. A negative divided by a negative is positive, which is why tangent is positive in quadrant 3. And in quadrant 4, I have a negative y over a positive x, which gives me a negative result. And cotangent, again, it's 1 over a positive number is positive, 1 over a negative number is negative. Trigonometric functions with radians. Find the requested ratios without using a calculator. Sine 3 pi over 4. So we're going to go around pi over 2, 3 pi over 4. Now we have a reference angle to the x-axis. This is 45 degrees, or pi over 4. Sine, well, so opposite over hypotenuse. So our opposite y is positive. Our hypotenuse is positive. So it becomes positive. Y over r. Well, let's see. Y would be, let's just call it our unit circle 1. Or, excuse me, our unit circle is r. So our opposite side, we have a 90-degree angle with a 45 and a 45. So we know that A and B are equal. Our hypotenuse is 1. A and B are equal. So it's 2a squared. So a squared equals 1/2. We'll take the square root of each side. It equals the square root of 1 over the square root of 2. Now I have to rationalize. Of course, the square root of 1 is just 1. but I will multiply both the top and the bottom times the square root of 2, and I get radical 2 over 2. Cosine 2 pi over 3, 2/3 of the way to pi. So 180 degrees in pi, 2/3 of the way there. Moves me 120 degrees around and leaves me with a 60-degree reference angle. So cosine in this quadrant is going to be negative, and cosine equals adjacent over hypotenuse. So we're going to use this 60-degree angle. Cosine 60 degrees equals x over r, which equals negative 1/2. Secant. Secant is 1 over cosine. Cosine, so ca, adjacent over hypotenuse. So secant is hypotenuse over adjacent. 7 pi over 6. So we've gone a little bit past 1 pi. We've actually gone past it by 30 degrees. So our reference angle is 30 degrees, or pi over 6. So our cosine of pi over 6 equals our x value over our hypotenuse, and that is square root of 3 over 2. So this is going to be negative 1 over the square root of 3 over 2. So we're going to flip our fraction. We get negative 2 over the square root of 3. I have to rationalize my denominator. So it's negative 2 radical 3 over 3. Tangent, 4 pi over 3. So 4 pi over 3 is 1 entire pi. And then I'm going to go 1/3 of the way around more, so another 60 degrees. This is my reference angle. So tangent 4 pi over 3. We're in quadrant 3 where tangent is positive. Now what we can do, though, is we can use the fact that tangent is sine over cosine. So we will use the sine of 60 degrees over the cosine of 60 degrees. The sine of 60 degrees is radical 3 over 2. Cosine of 60 degrees is 1/2. This is why you want to memorize these. So what do we get when we divide by 1/2? Well, we're going to multiply by the reciprocal. So we get radical 3. And cosecant. Cosecant is 1 over sine. So cosecant, 5 pi over 4. We will go 1 entire pi. And then we're going to go pi over 4 more, so 45 more degrees. Our reference angle is 45 degrees, or pi over 4. And as I said, this is 1 over sine. So let's take a look at the sine of pi over 4 equals the square root of 2 over 2. So cosecant will be 1 over the square root of 2 over 2, which is 2 over radical 2, but now I need to rationalize my denominator. So I get 2 radical 2 over 2, which is just radical 2. And we take a look back at our chart. Sine is only positive in quadrant 1 and 2, which also brings cosecant with it. So in quadrant 3, we're going to be negative. So negative the square root of 2. And the last one, cotangent. So 1 over tangent, or cosine over sine. So reference angle was pi over 4, or 45 degrees, and we're in quadrant 3. So cotangent, 11 pi over 6. Well, let's see. We go 1 entire pi and another 5/6. So that leaves us with a reference angle of pi over 6, or 30 degrees. We're in quadrant 4. Tangent is negative in quadrant 4. So cosine of 30 degrees divided by sine of 30 degrees. This is going to give us the square root of 3 over 2 divided by 1/2. And our answer will be negative. So square root of 3 over 2 divided by 1/2 means we multiply by 2. So we get the square root of 3, and it's negative in quadrant 4. Please take a look back through. You're going to, once again, you're going to want to make sure that you know your sine and cosine values for some of your basic angles, meaning 30, 45, 60, and 90, and then working from there to derive the rest. Thank you.